Hey Algebra 2 students, Ms. Kraft here. I noticed that you are getting started on your factoring trinomials lessons, so I want to make sure that you know how to factor correctly. And I watched the video that's posted on your course, and I don't necessarily like the way that that's done. And then I saw some of you showing me examples of how you would factor, and it's obvious that you've maybe learned a couple of tricks in the past or something like that. So I want to make sure that we know how to do this mathematically correctly, because you're going to need it later, and so it's important that you're doing the steps the way that they should be done. I'm going to start with distributing because that's what factoring is. Factoring is undoing distribution, okay? So I'm going to go ahead and distribute a problem, and then we'll factor it to undo it to show that it's exactly the same. So this first thing that I'm going to, or the first expression that I'm going to distribute is going to be 3x plus 1 times 5x plus 2. Okay, keep in mind that when we do the factoring part of this, this will be our final answer. I'm not sure how you learned to distribute. A lot of you learned it a long time ago, so you already know how it's done. But this step is really important, and most people skip it, which is why factoring becomes quite difficult. When I distribute, it tells me that everything in the first term needs to be multiplied by everything in the second term. So you should start by saying that 3x is going to be multiplied by 5x plus 2. And positive 1 is also going to be multiplied by 5x plus 2. Okay, so we have a common factor here of 5x plus 2 for each of these, because I can split up the numbers and just make sure that I'm multiplying each one to every term. So then I have 3x times 5x, that gives me 15x squared. And I have 3x times 2, which is a positive 6x. Then I have positive 1 times 5x, which is plus 5x, and positive 1 times 2, which is positive 2. Then I'm going to combine my like terms. My like terms are obviously my positive 6x and my positive 5x, same variable, same exponent. So my final answer here after distributing would be 15x squared plus 11x plus 2. Okay, that second step in distributing is what's going to be really important for factoring. So I'm going to go over to the right a little bit, and now we're going to factor what we got there, just to show that we are undoing distribution and that those steps are going to work exactly the same. We're just doing it backwards. Okay, so the problem that I'm starting with now, because I'm factoring, is going to be 15x squared plus 11x plus 2. Most of you start exactly the same, which is good. You should be identifying your A, B, and C terms, because that's what we use to factor. So my A value here is 15, my B value is 11, and my C value is 2. Signs are important. All of these are positive, so I have all positive numbers. But if you get negative numbers, please make sure you're identifying that you do indeed have a negative. Most of you then do the next step also, and that's identifying A times C. You do have to have A times C, because that's how we end up with that middle term. So AC, 15 times 2, is 30. And then B is the other important piece of information, and that doesn't change. We still have 11. So our job is to find two numbers that multiply to give me 30 and also add to give me 11. So it's kind of like putting together a puzzle. I generally start teaching this unit by listing all of my factors. You guys will find that there are sometimes more efficient methods, but this is the method that works all of the time. On a later example, I'll show you something else that I do that I've discovered works for me. If it doesn't work for you, that's fine. Find something that works for you and do it. So for this first example, when I'm identifying my factors, I just go through my list of numbers. So I'm asking myself, does 1 go into 30? The answer is yes, 30 times. So I know that I have 1 and 30. The important thing about factors is that because I'm multiplying to a positive 30, that means I could also use negative 1 and negative 30. So for every pair, I have 2 possibilities. Okay, then I'm going to ask myself, does 2 go into 30? The answer is yes, 15 times, so I have 2 and 15, which means I also have negative 2 and negative 15. I continue going down the list, so 3 does go into 30 10 times, which means negative 3 and negative 10, also a possibility. 4 does not go into 30, so I skip it. 5 goes into 30 6 times, which means I could also have -5 and -6. And then 6 is the next number that I get to, and 6 does go into 30, but we already wrote that pair, so we don't need to write it again. Once you get to a repeated number, that means you are done listing your factors. So these are our possible factors for 11x. Remember that we are trying to find what adds to give me 11. So I'm looking in this group of 8 pairs, and I know that 5 and 6 is what gives me 11. Okay, so that's the number that I'm going to use. When I go to factor my expression then, my first and last terms stay the same because I'm not changing a and c. So 15x squared stays 15x squared, and positive 2 stays a positive 2. What I am changing though is this 11x, and I'm splitting it up into the two numbers that I just found that multiply to AC and add to give me that 11. So this would be plus 5x and plus 6x. Okay. It doesn't matter the order in which you write those. If you wrote it plus 6x and plus 5x, that's fine also. You should know how to factor by grouping at this point. If you don't, then pay attention. It's super easy. We're just going to group our two terms that are next to each other together, and then we're going to factor out a GCF from each term that we've grouped. Okay, so we're looking for what number goes into both 15x squared and 5x. These both have 5 in common. They also have an x in common, so I can factor out a 5x. If you're unsure how to then get, what should be in parentheses here, I'm just going to ask myself 5x times, or 5 times what gives me 15, that's going to be 3, and then x times what gives me x squared, and that's an x. So I go through that way. 5x times 1 gives me 5x, so I get 3x plus 1 here. Now I'm going to factor a GCF out of this plus 6x plus 2. And these only have a positive 2 in common. I am going to keep that positive 2 there because it makes it easier when you regroup. So I have plus 2, that's going to leave me with 3x plus 1. Now, if you look at the example on the left where we distributed, although my factors are the other number, they are still in common, which means 5x plus 2 is what was multiplied by 3x plus 1 to get me my original expression. So once you have the same number in parentheses, that means that you factored correctly, and you just group what you factored out of those terms together. So that's going to give me 5x plus 2, and then that is being multiplied by 3x plus 1. It is not being multiplied twice, it's being multiplied once, each number times 3x plus 1 one time. So this would be my factored form of 15x squared plus 11x plus 2. I'll leave that here for a second for any of you writing it down or taking notes. And then I'm going to move on to another example. A little bit more complex, but really not super difficult either. Okay, our list of factors is just going to get longer. There is nothing different about how I'm going to factor. It's just that the number of factors that I have happens to be more here. So the next polynomial that we're going to factor is 8x squared minus 26x plus 15. Remember, like I said in the last example, your signs are important. So when I identify A, B, and C here, I'm going to make sure that I include those signs as well. Okay, so my A value here is 8. My B value is negative, so that's going to be a negative 26. And then my C value is positive 15. Okay, so the next step would be I'm going to multiply A times C. So A times C is 8 times 15, and that's going to give me 120. My B value, also really important, negative 26. So now I'm going to list my factors of 120. Okay, I'm going to do this the same way I did the last one. Sorry for my barking dog there. So we're going to do the same thing. We're going to list our factors here. This list is going to be a little bit longer. So I have 1 and 120, which means I also have negative 1 and negative 120. 120 is even, so I know that 2 goes into this. It goes in 60 times, so 2 and 60, which means I also have -2 and -60. 3 goes into 120. If you don't know your threes trick, if I add all of my numbers together, so 1 plus 2 plus 0 gives me 3. And because 3 goes into 3, 3 also goes into 120. So 3 goes into 120 40 times, so I could also have -3 and -40. 4 goes into 120 30 times, -4 and -30. 5 goes into 120. I know that 5 goes in because it ends in a 0. So 5 into 120, 24 times. So I could also have -5 and -24. 6 goes into 120, 20 times. -6, -20. 7 does not go into 120. But 8 does go into 120, I know, because when I multiplied 8 times 15, that's how I got it. So 8 and 15, 15 and 8. Oh, just kidding. -8, -15. And then 9 does not go into 120. The 9's trick works the same as the 3 trick. 1 plus 2 plus 0 is 3, but 9 does not go into 3, so it doesn't go into 120. But 10 goes into 120 12 times, so -10, -12. Okay, so these are all of my factors, because then if I multiply, or if 11 doesn't go in, and then I get to 12, and 12 is already in my list, so I'm not going to repeat that. Remember again that I'm looking for the two numbers that add to give me -26. Because I need negative numbers, I'm only going to look at this side here. Okay, I don't need the left side, I only need the negatives, which means when you write your lists, if you know what you're looking for, you don't have to write the complete list. When I add them together, I know that -6 and -20 gives me -26, so that would be my pair. If you knew that prior to getting to the end of your list, feel free to not write the entire list. So when I go back to factor, excuse me, remember that I keep my first term the same, 8x squared, and I keep my last term the same, plus 15. But my middle term gets split up into the two numbers that add to it, which in this case is -6x and -20x. Okay, the order does not matter. You'll just end up with a different factor group if you switched the -6x and the -20x, but your answer will end up being the same. So I'm pulling GCFs out of each of these. 8x squared and -6x, they have 2x in common, so I'm going to take out a 2x. That leaves me with 4x minus 3. Okay, when I get to this -20x and +15, anytime you have a leading negative, you must pull out a negative. So a leading negative means that I factor out a negative number. This is a leading negative, so regardless of what they have in common, I know it's going to be negative. They have 5 in common, and that's it. So now make sure you're watching your signs here also. -5 times a +4x gives me -20x, and -5 times a -3 gives me +15. Okay, notice again that I have the same number in parentheses, which means 2x and -5 is being multiplied by the same thing, which means my factors are 2x minus 5 and 4x minus 3. And this would be my final answer, factoring 8x squared minus 26x plus 15. Okay, again, I'll leave this here for a second if anybody's still writing anything down. I don't know if you're taking notes. And then I'm going to do one more example showing you a different method for finding your factors, because as your numbers get really big, and sometimes they do, your AC, it might be easier to use this method, and I just use a factor tree method. Okay, so my final example for you will be, let's do 12x squared. This will allow for a few more options. Minus 17x minus 40. Okay, so 12x squared, negative 17x, and negative 40. So I'm going to identify A, B, and C. That's not going to change. That will always be the same no matter how you're choosing to find your factors. So A is 12, B is negative 17, and C is negative 40. Okay, I still need A times C. Again, that doesn't change either, so no matter what method you use, I do those same first two steps. So AC here is negative 480, and B is still negative 17. Okay, so instead of going through and writing that whole list of all of my factors, which I can do, it just ends up being a lot because 480 is a big number. I'm going to just factor tree this, okay? I'm going to ignore the negative sign for now, but know that one number is going to end up having to be positive and one will have to be negative. So 480, I know I can multiply 10 and 48 to get to that. Okay, usually easiest to just identify your first easiest numbers. Then we're going to prime factor this, so we want to get down to our prime numbers. So 5 is a prime, 2 is a prime, I'm done with that side. 48, there are multiple options. It doesn't matter, again, how you factor this. So I'm going to do 6 and 8. 6 is not prime. That breaks down to 3 and 2. But both of those are prime, so I'm done there. 8 is 4 and 2. 2 is prime, but 4 is not, so I still need to continue factoring that one. So I have 2 and 2. Okay. This method might be confusing, which is why I said the first one that I showed you is probably the best method to use. But if you want to try this, it does work for me a lot of the time, just so that I'm not having to go through a really long list. Okay, so what I know is that 480 is 5 times 2 times 3 times 2. And I'm just writing the list of numbers that I see. Times 2 times 2 times 2. Okay, only the ends matter. I'm not worrying about the 10, the 6, and the 8. I broke those down, so those don't count. And then I just start grouping these numbers together differently to multiply them. So maybe I'm going to try 5 and 3. That's going to give me 15. And then I still have the 2, the 2, the 2, the 2, the 2. So I'm going to multiply all of those together. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I know that 15 and 32 are a pair. Okay. I can do, 5 times 2 times 3. Let me change colors so that I can represent that. So 5 and 2 and 3, I can group those three together. So 5 times 3 is 15, and 15 times 2 is 30. So I could have 30, and then these are the numbers that are left, 2 and 2 and 2 and 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So I also have 30 and 16, and I would just go through and make a list of a bunch of different numbers until I find something that works. Luckily for me, which is rare but possible, 15 and 32 is actually what works here. Remember that one of my signs has to be positive and one has to be negative because I'm multiplying to a negative 480. So my values that I need here are either 15 and negative 32, or negative 32 and 15. Oh, wow. Oh my gosh, that's twice I did that. Sorry about that. Or negative 15 and 32. We're trying to add to a negative 17, so I'm going to use the pair that has a larger negative number, which is 15 and negative 32. Sorry for my errors. I am human. Then we're just going to factor this the same way. So nothing changes from here. I keep the first term, 12x squared, and I'm splitting this b term into the two numbers that I found that add to it, which is positive 15x and negative 32x. And then don't forget to keep your c value at the end also. Then I'm going to go ahead and group these, So 12x squared and 15x, they have 3x in common, so I'm going to factor out a 3x here. That's going to leave me with 4x plus 5. And then negative 32x and negative 40, remember that anytime I have a leading negative, I have to factor that out. So I can factor out a negative, and then these two numbers have 8 in common. So that's going to leave me with 4x plus 5. Okay, my factors are the same here. So that means I can group what each of them are being multiplied by together to say that 3x minus 8 times 4x plus 5 would give me my original expression of 12x squared minus 17x minus 40. I hope that this has been helpful. When you guys are doing your discussion posts, please make sure you're explaining this way. I know it might take a little bit longer, but it is the effective method, and it's the one that works all the time, and it's the one that I'm looking for. Have a great Friday and enjoy your weekend.